So yeah, we're here to talk about something that I don't have to tell anyone in this room is a hot topic, which is the way that the mobility industry is being transformed by microchips and how microchips are being transforming the industry. It's a huge news topic for me. I write a newsletter about automotive technology in Canada, and the microchip shortage touches every part of the industry. We're seeing BlackBerry, GM, TELUS. Everybody is talking about software-defined vehicles. So we have a very deep bench of expertise that is going to have a lot to say today. So I have Warren Ali here, Senior Vice President of Innovation at the Automotive Parts Manufacturers Association. We have Matthew Burns, Global Director of Technical Marketing at Samtec. Kirk Ouellette, Vice President of Corporate Strategy for STMicroelectronics. And please take advantage of the Q&A with him because he is normally splitting his time between Tokyo and Geneva, but he's here with us today. And Pete Suma, co-CEO of Applied Brain Research. Do I get a mic? Do I stand up here? Okay, thanks. Okay. Can everybody hear me? Perfect. So let's just start out by kind of going around and everybody talking a little bit about what your company does and sort of the big way that all of the changes that we're seeing in the mobility space right now is impacting your company.
Hello, everyone. Thank you. Thank you to the team at Venture Lab for inviting us here to speak with you today. Warren Ali, and I'm the Senior Vice President of Innovation at Canada's Automotive Parts Manufacturers Association. This is our 70th year of existence, and we represent the OEM producers of parts, products, and technologies in the automotive sector across Canada. This is from the Tier 1 manufacturers on down. So some of the bigger names that you may know are Magna, Linamar, Martin-Rea. Collectively, this is on the manufacturing side. Pre-COVID, pre-NAFTA 2.0, about $35 billion a year, and it's staffed by about 100,000 skilled women and men. The way semiconductors and chips is affecting the industry, it's really about how technology is transforming the way we make vehicles and also the vehicles themselves, and how it's changing the dynamics of the business models of the OEMs and what that means for the suppliers as they move to business models that seek to not only sell the number of units of vehicles a year, but also trying to monetize every kilometer those vehicles travel. You're going to have to, as a parts manufacturer, look at how you're going to evolve your business to try to match that type of revenue generation to ensure that your products maintain their value over the life of it, not just in the integration thereof.
Thanks, Warren. Matt Burns from Samtec. It's a privilege to be here with Venture Tech, so thank you for the invitation. And it's a privilege to be here with our esteemed members of this panel. For those of you that are not familiar with Samtec, we are a global high-performance interconnect solutions provider. In essence, what that means is we make connectors, cable assemblies, RF, for a number of applications. One of those solutions is, or one of the markets that's definitely growing for us as a components manufacturer is automotive, whether that's being driven by autonomous vehicles, electrification, automobility, a lot of drivers in that space. Some of the influences that we continue to see affecting automotive industry, a lot of the sub applications in there are global technology trends, 5G connectivity, AI. So from a component provider standpoint, how that affects us is how do we make things within the cabin of a vehicle faster, smaller, denser? The old ways of routing data from point A to point B as fastly and quickly and as optimized as possible continues to be challenged. The type of processing that's being done within the cabin of a car, again, regardless of application, it could be ADAS, it could be the 5G connectivity, it could be the AI, implementing the AI locally within the vehicle, is changing design design methodologies, the type of component solutions, whether that's on the semiconductor side or the interconnect side, PCBs, the type of materials they use to tie things together. It's really forcing component vendors like Samtec, our competitors, our partners, the semiconductor companies, to continue to innovate and to invest. So, Samtec continues to look at these trends, look at these solutions, and innovate with the component solutions that we offer. Again, faster, smaller, denser. Sounds simple, but it's more challenging. A good example, instead of using Ethernet, automotive Ethernet is becoming very popular. Single twisted pair cable assemblies, totally different from legacy solutions. How do we route 1 gigabit per second through a car cabin? How do we route 10 gigabit, even 25 gigabit for some of the commercial protocols, PCI Express, Ethernet, that are slowly but surely supplanting CAN and some of the other protocol buses within automotive and transportation designs. So we tend to look at a lot of the trends we're going to talk about on this panel at the component level, but the trends do affect us in terms of the roadmap, investment, and how we continue to engineer solutions to meet some of the trends that are driving the industry.
It's okay. Hi everyone. My name is Kirk Ouellette. I represent STMicro. If you haven't heard of ST, we're a European semiconductor company, top 10 manufacturer in the world. And this year we're on track to do about $16 billion in semiconductors. So we do quite a lot, and about a little bit more than 25% of that is for the automotive space. So we're a pretty big supplier, providing globally into the automotive space. I'm the vice president of corporate strategy, looking at how we put our products together into systems. Glad to talk about automotive space here today. Lots of changes in this automotive world these days. It's one of those markets that, from a semiconductor perspective, it really doesn't change that fast, automotive, but things are changing fast recently. There's a lot of inflection points, and glad to talk about that, and glad to talk with people here about how startups can take part in that. Some of the things that I'm following in the semiconductor space, there's architecture changes coming in the automotive space, moving from just distributed connections in distributed computing, distributed nodes in the car, to more zonal architectures that are changing a lot of the opportunities. Things, even simple things like wire harnesses, they may get lighter and lighter as we go forward. And the electrification is a big topic, of course, that we're following quite a bit. ST is we provide a lot of components to many parts of the auto space, but power electronics is a big part of that, going into electric vehicles. Electric vehicles are roughly today maybe not taking off as big in Canada yet, but globally it's about, if you include batteries, hybrids, and other electric vehicle types, it's about 26% of the marketplace that's sold today, out of about, I think in another year we'll be back, maybe 2024 we'll be back to the pre-COVID levels of auto manufacturing, about 90 million a year, somewhere around there. And 26% of that today is electric vehicles. So, and a lot of new components coming in there. One of the interesting trends that we're following is new materials for semiconductors, things like silicon carbide and gallium nitride coming in to meet the needs of higher performance for electric vehicles. So we get longer range and more efficiencies, and how we use the batteries better. So silicon carbide is there today. It's just starting out, but ST today is now I think we're about the #1 supplier of power MOSFETs for silicon carbide, and silicon carbide's bringing this higher voltages into the automotive space, and higher voltages mean more efficiency, but also faster charging. So there's a lot of changes coming, not just from the electric vehicle side, but in the electric vehicle space. There's a lot of changes and architectural changes coming along there. So there's lots to talk about there. Maybe I'll leave it there and pass it over to Pete to talk about his area first.
Thanks, Kurt. So we're a company that's been around for about 10 years, and we've been commercializing algorithms that come out from studying brain circuits, believe it or not, at the University of Waterloo. One of the algorithms that we discovered was how a cell in your brain, or a function of a cell in your brain called a time cell, is so efficient at compressing signals over time. So believe it or not, the good engineers and my professor partner at Waterloo turned that into an algorithm for making time series AI super efficient and small, and then decided, well, how do you sell it? Let's make a chip. And so now this chip, hopefully taping out at the end of this year, is about $3 at sale. We make the chip for about $1.70. And that chip will do what a processor that, if you're trying to run full speech. So you know how Alexa has recognized your speech, processes what you said intelligently through a language model, then manages your dialogue, what you said before, what you're going to say next, and then talks back to you. Well, inside of that, there are 4 big AI models. And if you're in a car, you've got to think about when you go into a tunnel, or you go into a parking garage, or you don't pay your 5G connectivity bill, or you didn't sign up. If you're commanding your vehicle with voice, you've got to put the processing, that whole conversational logic has to go in the vehicle. So much so that if you talk to safety consultants, they're even thinking about making it mandatory, because you're driving down the highway. You've now been conditioned to tell the speaker system, the radio, to be quiet. And now you want full attention because the autonomous system has said, take control. And you've been enjoying your stereo on max, and you say, volume off. Well, if that's relying on a 5G signal to process that thing, it ain't going to happen. So you always see in cars local processing and cloud processing. So play me Britney Spears song that's, hit song, that's got to go to the cloud. But control of the vehicle has to be local, and it has to be fast, and it has to be inexpensive, and it has to be low power. And those AI models, to give full conversation, not the keyword stuff you're used to in cars that sounds like it understood what you said, but it doesn't, and it's frustrating. Full voice that you've all been conditioned to by your Amazon speaker can only be done in the cloud, unless you can make the model small enough to put on a chip cheaply. And so that's what we did. So it's not as wonderful as Alexa at all. It's not that size, but within the context of controlling your car, it's a full sentence dialogue interaction. And that chip is basically a time series processor, so the same chip can service the sensor needs throughout the vehicle. So the last comment I make, we're going to get into this in a minute, is the pressures that everybody was talking about on what's going on in the economics of cars, what we see from our small startup perch of trying to get into the industry and get these chips and services into vehicles and devices. There's a whole discussion about electrification and autonomy, and the war between those who make the device, the car, and those who provide the context, which is the entertainment services and the cloud services, which increasingly are leading to the purchase decision. And there's a lot of good studies on this. So there's also a bit of a war on who owns the customer when you talk about the difference between the cloud services and the vehicles. And those are some interesting effects. And they come all the way down the supply chain to affecting purchase decisions with chips and services. But we'll talk about that in a minute. And actually, Anita has an article coming out tomorrow surveying the entire field of deals in that space that I suggest you all take a look at.
Yeah, I saw Warren smile there when you said there was a war going on between the cloud services and the OEMs. Maybe a little bit of a strong word, but we can get into the debate further. So keeping it over there with you, Pete, and maybe Kirk, you could also weigh in on this. One thing that I hear, and one thing that really drew me to the automotive beat within technology, is that there is not just this one once in a generation disruption happening in the auto industry. There is the electrification disruption. There's also chasing level 3, level 4 autonomy going on at the same time. There's also 5G, smart cities, pinging everything, doing everything as much as you can on the vehicle. There's also building a platform that app developers will come to. So it's just disruption right and left is what I'm seeing, what I'm hearing, and you guys will be able to speak to that better. But in what ways could maybe some of these disruptions be opportunities for startups, for researchers to come in and put Canada's stamp on the next generation of vehicles?
Sure, thanks. Yeah, as I introduced, there's a lot of changes happening, and electrification's a major trend. I'll talk a little bit about that. Just before I get into that, let's maybe take a step back before we get into electric vehicles. If we look at a vehicle today, the amount of semiconductors going into a vehicle, the amount of functions that you're buying in a vehicle is going up and up and up. And so there's a lot more components going into a vehicle that have some sort of, whether it's some compute or a sensor. And so there's a lot more opportunities around all these pieces going into a car, even taking out these trends of autonomy and electrification coming. On electrification, as I mentioned, new materials are coming in for the electrification side. Today's IGBT silicon MOSFETs and MOSFETs are doing a lot of the work in the traction inverter in electric vehicles. But now wide bandgap semiconductors are starting to come in now. Even though they've been around for some time, the electric vehicle is really given a problem that these wide bandgap technologies are there to solve. And silicon carbide is fitting really well here because it can reach some of these high voltages you need. Things like 800 volts is where a lot of the OEMs are looking at now for their domain of voltage. So and that helps on both efficiencies and it helps on speed of charging. So that's one area of new materials coming in. So there's lots of opportunities there. And in the future, we see gallium nitride coming in, another new material that'll take that has a lot of special characteristics, high switching frequencies, and higher voltages that'll fit a lot of applications in the electric vehicles of the future. Things like onboard chargers, and then you have the charging stations themselves. So. From the electrification point of view, there's all kinds of areas to play, whether it's new materials, there's development of the power conversion itself, and then the battery technology, which we've seen some activity here in Ontario with. I've seen some new battery factories coming in. There's a lot more opportunities in that. There's a lot of new things to do on the battery side. Batteries need to get better, even though they're good enough today for electric vehicles. They need to be better, so there's a lot of innovation to be had there around many different areas of the electrification side.
I guess my comments would be more on the sort of startup end on software and maybe even some early chip observations. So in general, Moore's law is now, the data is, I think, very clear for now anyway. It's definitely slowing. It's plateaued. And that happened a while ago. And so the consequence of that is that as industry keeps trying to get cost, latency, power, performance to optimize, what you have to start doing is start looking at the workload that the chip is doing and matching that to the design of the software. So that means, and there's lots of good presentations out there on this. I've forgotten his name now, the chair of Alphabet, the famous semiconductor professor from Stanford, has a great presentation on this. The Cambrian explosion of chips is happening. And even STMicro, I was just yesterday looking at they're issuing chips now to do, specific work tests like anomaly detection, et cetera, et cetera. And the reason for that is the game used to be, we'll just make a smaller node. Let's, go from 22 nanometer down to 12, from 12 to 7 to 5 to 3 to 2 to 1, and let's keep going. Well, that game's not working anymore. And the fab costs of making chips that are down that low is rising on a per unit basis. And the cost recovery is challenged. So a more optimal solution is to design a specific workload software hardware. That is a fracture in the hegemony of the large chip makers, right? So that's a window of opportunity that they're not blind to and they're chasing. But I think that's an entrepreneur's crack in the door. It's very hard. I've done software companies before. I can tell you that a chip lift is way more difficult than I thought. Thanks to Venture Lab and the Hardware Catalyst Accelerator program here, really has helped a ton. But I would encourage people that are at the intersection of AI and chip design, if you come up with an AI algorithm that does a workload better, and there's lots of explosion going on there, don't forget to think about turning it into a chip as a monetization vehicle, and those are opportunities. I mean, we can get into more specifics if anybody's curious about or any entrepreneur wants to know, I have this idea for the auto sector, what's it like to go and try and get a first order? I'll happily sit you down and tell you our experience and how difficult it is, but also some ideas about how to help and who can help you in that journey. But there is a specific workload chip opportunity out there now that hasn't existed for a long time. So that would be my number one place to go look.
Good advice. I don't know if anyone from GAN Systems is here, but I think some interesting work going on from an Ottawa company on some of that stuff. So I want to make sure we get to audience questions. So this is going to be our last question, but I do want to get to this from Warren and Matthew. So when we're looking at the hardware inside the vehicle, the way from the ground up that's being built, I think with this microchip shortage, a lot of people were like, okay, you can't get me my card because it's missing a chip. Give me one without a stereo. We'll put the stereo in later. We'll put the Bluetooth in later. But it's actually, we're talking dozens and dozens here. And people, I think the general public is waking up to the importance for the first time. So how is, all of these changes, all of these inflection points changing the way that vehicles are being built kind of from the ground up?
Okay. From an interconnect component standpoint, I think that it's forcing companies like Samtec, our competitors, our partners to think holistically, rethink the design model. You mentioned, I don't know that there's any industry, not only in addition to automotive, but almost any industry that wasn't affected in one form or function by some of the semiconductor shortages we've seen over the last 12 to 18 months. There's a technology that Samtec offers that relies on an 8-bit micro from one of the solution providers, not present in this room, by the way, not ST. Sorry, Kirk. But anyway, that affected a multi-million-dollar piece of business for us that we've had to work through. We've had to re-engineer and come up with unique solutions to get past that so that we can continue to service our customers. And it was $1 micro. So that's, from Samtec's perspective, that's just one microcosm. It's a microcosm from one small piece of business that's affected overall the automotive industry as a whole. In addition to addressing such things as the silicon shortage that we've seen over the last 12 to 18 months, I think too that with some of the trends, the disruptions that we've talked about when it comes to designing next generation vehicles, next generation automobiles, whether it's autonomous, whether it's electrification, whether it's mobility, Peter talked about AI within the system. That's really affecting. How do I route data? And again, where we specialize in is how do I get all that data throughout the system? AI functionality within the car requires gigabits, terabits of data on a day-to-day basis, not only being routed in the car, but through the 5G connectivity, 6G connectivity, coming in the next few years, from the vehicle to the cloud to the network. So again, I kind of said this earlier, how do we make things faster? How do we make things smaller? How do we make things denser? When you look at that electromechanically, optically, RF, which is where Samtec plays, it's looking at, can we change the metallurgy? Can we look at different material science capabilities? How can we design the plastics on our interconnect or some of the other dielectric materials within our cable assemblies to make them faster, make them denser? And not only do we need to get to the performance levels that's needed to route this data all throughout the car, and in essence, I've heard not only at this panel but in several other trade shows and other professional events, vehicles are becoming data center on wheels. And maybe that's an oversimplification, but it helps to understand the amount of data that's being produced. So how do I get that routed all throughout the system? Is it single pair Ethernet? Is it PCI Express? Obviously there's personal area networks with RF connectivity. We all love Bluetooth connecting to the console and the audio within our car while we're driving. All these applications really demand and also are receiving innovation to make the interconnect, whether that's copper, whether that's optics, whether that's RF, smaller, faster, denser.
This is one of those questions that, depending on which off-ramp you decide to take on the highway you're driving, it'll take you down a completely different road, and that road will go on for a very long time. So I'll try to limit where I go with this. But I mean, where technology is converging with the automotive sector, it's affecting it in so many different ways. I mean, just some basic things on chips. I mean, just Google Ferrari and STMicro. The latest CEO that Ferrari hired. Ferrari is by far, when everybody thinks of them, you think F1 racing, you think super fast sports cars and whatever else. The newest CEO is one of Kirk's former colleagues from STMicro, somebody that came from the chip side. I mean, you got to understand what kind of a revolution that is in automotive, that you didn't hire a mechanical engineer to be the CEO of your organization, because the OEMs, their business models have always been around making lots of things that move. And now it's you're bringing in somebody that doesn't make anything that moves. They make a lot of them for sure, but they're going to be making business decisions on a vehicle manufacturer. So that's one way. I mean, we talked about the features in the vehicle. Well, if you make all of these various parts in the vehicle, but the value add now comes from an electrified tailgate. Not everybody is going to be big and can open up things or tall enough to reach. But if you're now having to make a decision as an OEM to say, well, what are we going to power in a vehicle? Are we going to have power heated seats? Are we going to have powered seats? Are we going to have a powered tailgate? And we're having to make those decisions where consumers are expecting all of these creature comforts in all vehicles, regardless of value. And now you're limiting the consumer's ability to buy it. Our members aren't consumer facing. Nobody knows a Magna part, although they do make lots of vehicles for lots of OEMs. So they're not a brand that the consumers interface with. But if all of a sudden the consumer's having to make a decision for the vehicles that you contribute thousands of parts to, and they're not going to buy them, then you have to start making decisions as to how are we going to be supplying. And then you just look at mobility in general. The OEMs are moving more from just selling units to trying to own journeys. And they're investing up and down the mobility chain. They're investing into micro mobility. They're getting involved in the eVTOL movement and into aerospace. And you also see the investments beyond the selling of the vehicles themselves, but they're all getting into some way to sell electrons. They're all exploring at least some ways to sell kilometers. And of course, they're all looking at selling services. If you're a parts manufacturer and your business model was, well, they sold 1 million cars last year, I want to have 1 million parts on them. And now they're going to sell 1.2 million next year, so I want to have 1.2 million parts. Well, if the business model is now no longer predicated on, well, we want to sell more units next year, it's, well, we don't necessarily have to sell 1 million more because we're going to make money on the kilometers of the vehicles we sold last year and the ones we sold the year before. Now, all of a sudden, what's my business model if I'm not getting involved in that as well? And so it's how do we start working with those chip manufacturers to add some embedded intelligence in some of those things that we do make? Because finding real estate for technology in the vehicle is not easy. You have software, you have chips and whatever else. You still got to figure out how you're going to get that on a car. Well, our members make thousands of stuff that are already in cars and will be in cars for years to come. So we already have real estate that we can partner with companies that are developing tech and software to derive value from the vehicle. So how do we start having those relationships and conversations to allow your business models to grow and allow our business models to adapt and add value? There's questions in all of that. There's some solutions along the way, but we're kind of finding out those answers in the doing.
Speaking of questions, should we open it up for 5-10 minutes? Are we passing around mics or people kind of raising their hands or? Oh, we have mics. Fabulous.
Hi, Cedric Canu from Digito in Quebec. I'm in the semiconductor space. I've helped companies put semiconductors in automotive. We had a meeting with Volkswagen, and they said in the last Porsche Taycan, they have 8,000 semiconductors, which is mind-boggling. My question is, as a semiconductor manufacturer, the sales cycle from R&D to having $1 revenue is like 7 years. With the change in the industry and the pace of innovation, is this something that will shrink? And what's your view?
So I can't tell you that I can confirm that like we don't have a major contract. We do have LOIs. It feels like it's shortening based on what people tell me. I haven't been in that game long enough. You would know better than me, but for newer technologies, what I'm seeing, at least in just the journeys I've had, the makers are, the R&D teams and the product teams are actively interested in understanding neuromorphics and understanding AI processing, efficiency, power. So, and from what I'm told, like the windows and the doors are open much more than they ever have been before. Before it was like, you know, you'd have to sort of exist for 3 years before you might get a meeting kind of thing for anything serious. That said, there is a huge gap past the engineering interest. And even if you have absolutely proven, like the math is proven, the data, even if you get the PhDs on the engineers on their side to say, you're absolutely correct, this is better. There's a hell of a gap between there and the car. And so my fear is that I'm going to live exactly what you described over the next couple of years. But the things we've done in response are, when you have a horizontal technology like an AI that does voice and sensor, it can go in a lot of places. Some places, some real estate's really hard to get into, like core control of anything, the safety regulations, et cetera. Peripherals, UX, UI, voice interface, but not even the main voice interface, but subsidiary voice interfaces outside the vehicle and things like that for limited particular uses. So I think it's a bit about the doors are open because everybody's competitively uncertain. I think to Warren's point about what the future holds, and it's actually that active. It's not like they're sitting there with the answer from what I can tell. And this platform war of features and the concern over who's going to own the stickiness of the purchase decision. Is it the platform? Is it the vehicle? Is that a threat? And what features they have to keep up with are opening the door. And you have to be creative and find the easier to enter real estate and functions on the vehicle to get in. As to whether it's going to take 7 years, I dearly hope not to get to scale. So.
Yeah, I'll just add a couple comments. It certainly feels like things are moving faster, but I don't have any proof that there is going faster. You still have the challenges of building a car that we want to buy with reliability and safety requirements, and adding more software really doesn't speed up the development. It may slow it down, but things do seem like they're moving faster. One of the comments I do want to make is there is some short circuit things happening where, and you talked about VW, the OEMs are coming in and talking directly to the semiconductor companies now. And not that directly speeds up the development, but it may speed up the specification part in the beginning of the part, so that the OEM decides, yes, I want this feature in there, and that happens faster. But I can't say if the development is moving any faster. I don't have any proof of that, and it feels like it because there's a lot of change going on, but it's hard to say if it is or not.
I know the question was sort of semiconductor focused, but I'll answer it from an interconnect standpoint. One of the things that we've observed at Samtec, at least anecdotally, is that when dealing with some of the legacy manufacturers and some of the legacy OEMs, there's sort of a business methodology or design methodology that the industry stuck with for a long time, and that's the industry is being forced to adapt because of all the innovation that's being done. When working with some of the disruptors, whether that's in the electrification space or in the autonomous space, they're not as, how can I say, maybe tied into legacy ways of doing things. And because they're the disruptors, I think that their design cycles and their implementation cycles are accelerated just because of the nature of their solutions. We've definitely seen that from a certain perspective on some of the technologies. We have been able to design in off-the-shelf solutions for some of the disruptors. We've also been able to design in newly developed platforms, and it definitely hasn't taken 7 years to go from design to to purchasing. So I think you're kind of seeing a bifurcation, at least from our perspective, a bifurcation in terms of how the market's going. And my guess is with the more innovation that you're going to see, especially with electrification, autonomous, that the legacy providers are going to have to speed up.
I don't have any empirical data to speak to this, but if you just look at some of the breadcrumbs that are happening in terms of how investments are being made, so you're seeing a lot more CVC activity from the OEMs and from some of the larger tier ones. Well, they're investing in them and they're investing outside their companies, and they're trying not to bring them in-house to, you know, impart all that legacy corporate culture and everything else on them to let the companies grow. But they're also investing in them because they're in all likelihood the first best customer of some of those technologies. And so by doing that, you know, when those profits and those values lift, then you get the lift from the investment, but then you're also hoping to learn more to get the value add in your own product. So therefore, when you roll out that product, your consumers and your buyers are better. So when you see more of that activity happening and you're seeing that spreading out and it starts to now become monetized and those companies start rolling out, you'll probably see some of the value. I mean, some of the things that happened here just in Toronto, Ford acquiring Automotive off of Bay Street and then moving it to Green Hills. So there's some examples like that. And then when you just look at if you're expecting the overall use rate of these vehicles to start increasing, you know, it's how does that change when, you know, the lifespan of vehicles 5 to 6 years or 200,000 kilometers when it's parked 95% of the time. Imagine now when you get into the cases where the vehicles are becoming used more and more often. So then the overall use cycle. So you're going to go through that technology much quicker. So part of the challenge is you're going to put something on a vehicle. They're not going to recall it to take out stuff to put new stuff in. So it's kind of embedded in there. So as long as you have value that can continue to grow while it's resident in the vehicle, but if you're going to use the vehicles more often, and so then more new vehicles, then you're going to have greater opportunity for the hardware to create, because the vehicles maybe not selling as many per year in terms of new ones, but they'll be replacing the old ones much faster. So those are just some of the business things that are happening that will hopefully move the yardsticks closer to the business development on the technology side when it comes to mobility.
I know we're close to time, so maybe like 1-2 more rapid fire round questions.
Hello, yeah. Cyril from Bosch Automotive Semiconductors. Just one comment to Cedric's question. From my experience, things are not going faster, but we have to do more in the same time. So basically, the changes are a bit deeper. The question I would have to the panel is basically, you know that basically the automotive industry is really repellent in regard to innovation coming from the outside. So whether it's an OEM or tier one, people are really into the mindset, do it yourself. I mean, nobody can do it better. So what advice would you give to any startup or entrepreneur out there? What should they do and how should they do it to be able actually to pierce this permafrost and to actually be successful in not only selling, but cooperating with the automotive industry?
I'm going to do a plug because I see our friends from Bosch here, but I just look at some of the examples that we have. So there's a company based out in Waterloo. It's a cybersecurity company that's called eScript. It was formerly another company, and the founders from there sold stuff to BlackBerry, but they are now a Bosch family company because ETAS bought eScript, and ETAS is one of the Bosch companies. So one of the things that you may want to look at is being more connected to the markets where a lot of these buying decisions are being made. And so one of the things that I'll plug is working with some of our federal trade commissioners. So employing staff and having those people that can be those door openers in foreign markets. One of the things that I'll recommend, it's because it's through the trade commissioners and having these doors in those places that they're able to connect with companies like a Bosch who may not have a tech scout or the buyers resident in these markets, but you can then get in front of them through some of those accelerator programs. In Germany, the three that we know or we worked with is Startup Garage, Plug and Play, Startup Autobahn, via VW's Innovation Garage. So some of those things like that, that's free. And it'll allow you to connect with some of your customers in foreign markets. So that's just one.
Yeah, so we live this. So definitely trade commissioner service has been, so it's all about getting introductions. In terms of your part in it, I mean, you're from the industry, you would know you've got to have the feature sheets, you've got to have the performance data, you've got to have a quantitative way of proving that you've got something better. You've got to do a hard market scan, which is, I found very difficult to find the selling prices of the competitive chips that would do the same workload. That was difficult. Finding their power and performance specs was quite easy because those are published typically. And you've got to work up some demonstrations. And it's basically, you've got a high bar of getting all the details ready for consumption by incredibly skilled engineers on the other side. In our particular case, because the advantage is coming from a mathematical algorithm, we had an additional problem, which we found very difficult, that even despite the incredible electrical and mechanical skills we find in the automakers, even in their best R&D teams, to be blunt, keeping up with my partner's mathematical skills can be challenging. And so we had to try and drag people through mathematical proofs and things, and it was painful and still is. I've got videos for it now, and we tried to explain it, you know, in the 1-minute version, the 5-minute version, and then the hour-long video, which I send selectively to some people. I say, "You sure you want this?" But it's that there's no replacement as blocking and tackling. I played football in college and coached at U of T, and head down, feet pumping. That's what we used to say on the line. You just gotta go, and you can't give up. And I can tell you that, you know, for fun stories, it's that hard. But Trade Commissioner Service, Warren gave me introductions. LinkedIn has been enormous. That's where I started. Avinash here, God, everybody on the Venture Lab Hardware Catalyst side. I just asked them of the humorous calls when I first started this about a year ago, after we'd spent 2 years. Well, my partner spent 20 years developing the technology, and then we've about 2 years have been trying to commercialize, and really only for about 8 months to 12 months now selling. And we just basically had to find people that would give us the time of day, and it was constantly like, how the hell does this industry work? How do they buy? How do you get, who do you talk to? Like, how do you get into a car? Oh my God, really? And then, you know, one of our advisors, Paul Slabby, said to us at one point, "Are you sure you want to build a chip company going into automotive?" And, you know, so what's the old saying? If I'd only known, you know, so we're already over the cliff. We're sailing downward. Let's hope we get the wings. You know, we've got really strong technology, but that doesn't matter as much as I would have hoped. So blocking and tackling is my answer, and connections.
Maybe 30 seconds. When we look at interconnect within the automotive industry, you know, Samtec is a small but fast-growing player. Some of our big competitors, you know, sell more within automotive than the size of our company. The way that we're winning is out innovating and out servicing. So trying to find the opportunities for innovation, trying to find solutions that some of the disruptors may need. Maybe it's, you know, maybe we're taking on things that some of the other folks wouldn't, but that's out innovating and out servicing. And I think that same business model can apply semiconductors or any type of component or solution provider that wants to get into the automotive industry.
One more short comment. Coming from a semiconductor perspective, non-automotive, I know the automotive industry is changing quite a bit, and it was a traditional industry with a lot of traditional OEMs and tier ones. If you're a startup trying to break into that, if the cars of the future are, I think someone mentioned, maybe it was you, Warren, that the car will be a mobile phone on wheels, maybe we need to look at how people got their startups into spaces like mobile phone or other types of platforms. I don't know if my former colleague that now runs Ferrari would like to hear that it's a mobile phone on wheels, but I'm sure there's the conversation with the but looking at it from that perspective of like the reference design perspective, when you come from a semiconductor point of view, people one of the ways of getting a new chip into a system is find the people making the reference design that are building that platform and sneak your device into their platform, and then they promoting it to these OEMs. So that's more of a traditional way. In mobile phone, like if you wanted to get into a mobile phone space in a standard mobile phone Android base, go talk to Qualcomm, go talk to MediaTek, get on their reference design and convince them to do some software there. This might be a route. Maybe we're a little bit early for that for the automotive side, but that may be a way to look at it. It may take a little while, but I think we'll get there.
I think they're going to bring the cane for me pretty soon here, so we might have to wrap it up. Maybe get your feet pumping, block and tackle over here with some of our panelists, pull them aside after, and pick their brains some more. But thank you all so much for the conversation and for listening.